Hello, today is May 25th, 2024. Today we're going to talk about geometry, and then we're going to do the final review. I've noticed after the long weekend, we're going to have a geometry final test. Again, this is just my personal understanding regarding the final review. It could be completely different from what your teacher expectations. But again, those I personally believe is the very useful information, whether it's going to be covered in the final or not. Those are important subjects you all need to grab. So, without further ado, let's go ahead. The first thing I want to introduce is called the square. So the square is something like this. And then if I use the same hash mark, that means all the four sides AB equal to BC equal to CT and equal to AT. And then let's say the length is A. And then the parameter of the given square ABCD is going to be A, because that's the side of this one, plus another A, plus another A, plus another A. So that will be 4A. The area of the square is going to be, by the way, square, the angle is 90 degrees. The area is going to be A times A, which is A squared. Okay, again, if we look at the angle, the sum of all the interior angle is 90 plus 90 plus 90 plus 90 degree. So 4 times 90 is 360 degree. Again, remember last time we using the sum of all interior angle, that is n, which is the number of the side, in this case 1, 2, 3, 4, and subtract 2 times 180 degree. In this case we have 4 sides, subtract 2 times 180 degree. That will be 2 times 180 degree, which is 360 degree. Again, those two agree. Okay, so the next thing I want to introduce is something look like that. Yeah. Those are the 90 degree angle, and then we'll name this as ABCD. However, notice when I use the hash mark, I use the one hash mark, means AD is, AD is equal to BC. For those two sides, it's different from AD and BC. So that's why I use different hash mark. So in other words, AB is equal to CT. Okay, let's say AB equal to A, AD equal to B, then the parameter will be the sum of all the lengths, right? It's going to be A plus this guy B, and since this is equal to that, so this is also A, and the last BC is B. So if we count those A's, we know there's 2 A's. Similarly, we have 2 B's. We can factor the 2, and then we got 2 times A plus B. And then the area is simply just A times B. A times B. Okay, now the next thing I want to introduce is the oh, by the way, this is called, did I write down the rectangular? Rectangular. So the one we're just talking about is a rectangle, or rectangular. And then the third one is triangle. Before we dive deeper into the triangle, let's again redraw the rectangle that we just drew it. So it's A, B, C, D, and then those two sides the same, top and the bottom. I'm sorry, top and the bottom are the same. Okay, and then we got 4 angles. They are 90 degrees. Now let's connect the diagonal, which is B and D, for instance. And then notice here, it forms a triangle. Okay, then the perimeter of the triangle, let's say this is the B, this is the A, and then the diagonal we call it C. Then the perimeter, very simple, it's just A plus B plus C. And then what about the area? So before looking at the area, then we look at the whole rectangular area. We know the area is right here. It's A times B. Notice the diagonal separate the rectangular into 2 exactly the same size triangle. Why? Because look at this. This is the side is A. This is the side is A. This side is B. This side B. And then the angle they formed is 90 degrees. So based on the theorem we learned at the beginning of the semester, so that those two are exactly the same triangle. Since the whole area of the rectangle is A times B, and then that including 2 identical triangles, so that's why the area is half. Okay, so that's kind of like intuitive understanding of that. What about the triangle like that? This is just a random triangle. Let's say A, B, C. And then if this guy is B, and then since there's no 90 degree angle, right? So we need to draw a line, and then this we call it high, H. So for this triangle, again, the area is still going to be half of base times the height. Here, base, we specifically say the base length. Okay. So, let's keep moving on. The next thing I want to review is circle. This is the center, this is the radius, R, and then the circumference, RENC, of the circle is 2 pi r. Notice for the circle, we typically use the circumference instead of parameters, but they pretty much the same thing. And then the area of the circle is pi r squared. So the next thing we're going to review is sphere. By the way, this is circle. For the sphere, so we have a new concept called surface area. I mean, if you have a paint, and then if you try to cover the whole surface area, let's say you got a red paint, and then after you touch the ball, and then the whole ball become red, that is your surface area. Surface area. The surface area equal to 4 pi r squared again. The radius is r. And then the next thing we're going to talk about is the volume. Volume you can think of this way. If you open a very tiny hole right here, and then you pour the water inside, if the whole thing is filled with the water, that's called the volume. That's 4 over 3 pi r cubed. Okay, and then the next thing we're going to talking about is called the cube. What is the cube? Cube means every side, no matter where it is, they are equal. Let's say they are equal to A. Then, how do you calculate the surface area? Okay, so if we look at the bottom, it's going to be A times A, right? Which is A squared. See how many we have? We have bottom, top, and then we have 4 sides. So total we have 6 of them. So that's 6A squared. What about the volume? The volume, let's say again, the base times the height. The base is A times A squared. The height is also A. So it's A. So it's the A cubed. Okay. So the next thing we try to talk about is called the light prism. How does the light prism look like? It looks like something like this. Okay. Okay. Something looks like this. Let's say this side is A, this side is B, and then the height is C. Again, the surface area is kind of like a cube, but the only difference, by the way, people call this cube. By the way, the difference is that each side is a different size, but this cube, each side is the same. So how do we do that? Let's say we found this area, that is, again, that's the surface area. Surface area is going to be A times B, right? But exactly surface area, we have 2 of them. So it's going to be 2. And then we have two side, which is C, B, right? So again, we got 2 of those, so it's 2BC. And then the last 2 one is the one in the front and the one in the back. So that would be front and back. That would be 2BC, because this is a B, this is a C, right? So it's 2AB plus 2BC plus 2. Wait. I made a mistake. Let's go back again. The bottom and the top is AB, 2AB. The side actually is BA, because this side is A. That's my bad. So it's BA, and then the front back is BC. So it's 2AB plus BC plus BA, which is this guy. Okay, now what is the volume? The volume again is the base area times height. Okay, and then that equal to A times B, and then the height is C. Okay, so where we are going to use the base times base area times the height. So you can use a test, like I always tell my students, to find the intersection like that. This is basically your imaginary cut. Imagine this is your hand, right? You are holding this, and then this is a pretty sharp knife, right? So if you parallel with this plane, you cut in anywhere, they all give you the exactly same area, which is the same as base area. So that is the base times the height. For instance, if you got the exact same thing, even though my actual drawing look a little bit different, but just to your imagination, this is identical as this. What if my cut is like that? I'm going to cut it that way. Okay, so again, this is my hand. So notice I cut this way this time, right? Instead of like cut horizontally, I cut this way. Again, if I cut this way, so this is A, B, and then the side C, right? So whatever the cut area is going to be my base area. So actually volume equal to the base area times height. Notice the base area is what? Is B times C, right? B times C. And then the height in this case is A. Notice for the multiplication, we can use a rule called commutative law, right? So in other words, if we switch their position, their product is the same. So we can change this to A times B times C. So that would be exactly as there. So in other words, as long as you find the base area, no matter what, where you cut it, as long as you cut it parallel each other, then you can kind of like moving back and forth, and then the area doesn't change. I mean, the intersection area doesn't change. Then you can use this. Another thing I want to remind you is, what about if we push this a little bit? Imagine this, the whole chunk right here is the tofu or jelly. If we push it, slant it, right? So if we slant it like that, okay. But as long as the base area and the height is H, I mean the same height, I'm sorry, is the C, and then this is the B, this is the A, then the whole volume in the tilted prism is still going to be A times B times C. So that's very important. Okay, so next time we're going to continue the review. This is just a part of it. I'll probably stay with this until I finish the review, and then we'll move to algebra. Okay, with that being said, you guys have a nice evening. Bye-bye.